All right, this screencast is going to talk you through how to draw the proper structure of different atoms that we're beginning to discuss in class. We're learning atomic theory because we're learning about the subatomic particles that make up matter, right? As we study electrostatics, we're really going to be focusing on how charges are transferred from objects. So really by learning about atoms and the atomic structure, we're going to be able to understand where the electrons come from that are going to be transferred from different objects. So here goes. We'll start off with beryllium. It's number 4 on the periodic table, right? It's an element. Its symbol is Be, and its atomic mass is 9.012. So atomic mass is going to be a value that you'll need to make sure you know where to find it. It's typically represented at the bottom of the periodic table, or of the actual element little square that's identified. So the atomic number is always going to be the particular number. The element name is going to be labeled somewhere in here. And I draw them a little differently just to give you a little bit, the visual cues. Some periodic tables just kind of flip them around a little bit. The symbol, in this case beryllium, is Be. Let me draw an arrow here. So if I draw this out, which I want you to, I want to make sure you understand that there are rules to the drawing. There are rules to the game here. The rules are, I've got electron rules. And the other rule is that I have a nucleus rule. So a couple things going on here. I'm just going to start off by jumping right into beryllium. I'm going to kind of keep this one here in the picture, this electron rule set here. And I know that I have, it's element number 4. So number 4 as an element tells me that it has 4 electrons and 4 protons. I know that it has 4 and 4 of each because it is electrically neutral, meaning it has 0 net charge as this element naturally occurs in nature. So I know my electrons, I know my protons. Now I'll have to solve for my number of neutrons, and I'm drawing these out a particular way. I draw 4E minus because I think E minus tells me that electron's negative charge. It tells me information. I draw 4P plus because P, protons, have a positive net charge, and neutron has no charge or 0 charge, however you want to interpret that. So in order to solve for my number of neutrons, I will go back to my periodic table piece that I have this little square, and I need to take my atomic mass minus my atomic number. And if I go back and apply the numbers here, I've got 9.012. I round this to 9. I've got 9 minus my atomic number 4. And it tells me that if I subtract out my 4 protons, it has 5 neutrons located in its nucleus. So I'm going to start drawing this, and I'll draw this one. This one will be drawn a little smaller. So I'm going to start off by drawing my nucleus, right? I know that I have 4 protons, and I have 5 neutrons. I have protons and neutrons in my nucleus. In my first electron shell, I have 2 electrons occupying that space. So, I can actually draw them as E, or I can actually just draw 2 E minus, right? 2 electrons in this first shell. And I know that I have 4 total, so that means in my second electron shell, I have 2 more electrons. And here I could say that this would represent 4 protons, 5 neutrons in the nucleus, 2 electrons in my first electron shell, or my electron orbital. And I have 2 electrons in my second, or valence, I'm going to start referring to. My valence implies it's an outermost electron orbital, or my outermost electron shell. So we'll crank it up a notch. We're going to use the same rules to apply here. And I will draw this one in a little different color, just to kind of differentiate. So check this out. So I've got sodium. Let's see, element number 11. So the atomic number is 11. My element name is sodium. The symbol is Na. And the atomic mass units are 22.989. So I'm going to use the same rules here. So sometimes it takes a little practice for you. So that's what we're doing. I'm trying to give you some ammo to work from. So here goes. I got to go back to my rules here. I know that it's element number 11. Start with what you know. I know it's element number 11. So I know that this element here has 11 electrons and 11 protons. I know that it has no net charge. It is electrically neutral. So it has no net charge. So however many pluses I have, I must have the same number of minuses, right? Electrons and protons. So now I find my number of neutrons. My number of neutrons is going to be my atomic mass minus my atomic number. So I can plug this in. I've got 22.989. I round that to 23 minus 11, and I get 12. I have 12 neutrons here. So I know that I have 11 protons and 12 neutrons located in my nucleus. So I draw my first electron shell around here. I have 2 electrons here. 2 electrons satisfies my first electron shell. But I have 9 more. Remember, I have 11 total. So if I've used 2 already, I still have 9. Well, I can only fit 8 in my second electron shell. But notice, I've only used 10, and this has 11 electrons. I've only accounted for 10 of the total 11. So I'm going to draw a third shell, which I call my valence, right? My valence is my outermost electron shell, and it only has 1 electron in it. And notice if I add these all up, I've got 2 plus 8 plus 1. I have 11 electrons accounted for. I have 1 electron in the valence shell, where valence is the outermost electron shell. So this should help give you a little bit of an idea. If you want, I recommend you try a couple on your own. Why don't you create or find online a box? Why don't you try to do the following? Why don't you try to work on bring these to class tomorrow, and we'll try to solve them in class. Solve for number, let's go with number 6, number 14, and number 18. There you go.